Okay, so we've looked at the notation that we use for inequalities and also how we represent, how we draw them on a number line. The next step is to solve some linear inequalities. And actually, what we're going to do is, before we start solving linear inequalities, we're going to think about solving linear equations because the two topics are very closely connected. So we'll just do a quick recap on solving equations, and then that skill will transfer to inequalities directly. So on the PowerPoint, there's all of these questions and answers. I'm not going to go through all of them. I'm just going to go through a handful just to make sure we're happy with the ideas. And you can practice the rest on the PowerPoint if you want a little bit extra practice. So if I start with, say, 2x plus 9 equals 19. We start with this one. Remember that the goal of solving an equation is to end up with x equals some number. So our aim at each step is to get less stuff here with the x. So the first thing I'll do is I'm going to get rid of that 9 by subtracting it. If I subtract from the left, I also have to subtract from the right hand side. So that leaves us with just 2x here, and then 19 subtract 9 is 10. The next step is I've got 2x's and I only want 1. I can fix that by dividing by 2. So if I divide both sides by 2, I end up with x, which is what I want, and 10 divided by 2 is 5. So this equation has an answer of x equals 5. If I start again with one of these on the other side, I'll pick a slightly more awkward one. So I've got 1 equals 4x plus 5. Well, the first thing we need to remind ourselves of is it doesn't matter whether I write x equals something or something equals x. They're equivalent. I can swap them around. It makes no difference. Because my x at the moment is on the right-hand side, I'm actually going to aim for x on the right and some number on the left. And then I can just swap it when I write down my final answer. So what do I want to do first? I want to try and get this x on its own. So let's get rid of this 5. So subtract 5. And again, if I do it on the right-hand side, I've got to subtract it on the left-hand side as well. So I've got 4x left over here. 1 subtract 5 is negative 4. And that's fine, no problem. The next thing I want to do is I've got 4x's, so I want to divide by 4 because I only want one of them. Again, I've got to divide on both sides. And I've got the x that I wanted now. And what's negative 4 divided by 4? Well, it's going to be negative 1. And then just because it gives some clarity in answer, I'm going to swap them around. So x equals negative 1. That's it. Straightforward. We can look at some slightly more awkward ones. These are a bit trickier because there's an x on both sides of the equation. So if I look at 7x minus 42 equals 2x minus 7, I still want to aim for x equals down the bottom, but now I've got x's in both places. So actually my first job is to pick one of these to get rid of, and the trick is always to just get rid of the smallest one. So I want to get rid of my 2x, and I'll just do it by subtracting. So I'm going to subtract 2x from both sides. That clears this out, so I only have the negative 7 now. Over here, the negative 42, that's not affected by taking 2x away, but 7x take away 2x is 5x. And now I have an equation that looks just like the ones we did last time. So I want to get rid of the 42. This time I need to add it to cancel it out. So I need to add 42 to both sides of my equation. So I have 5x equals, and then negative 7 plus 42 is 35. And then final step, I want to divide both sides by 5. 5x divided by 5 is x, where we want it to be, and 35 divided by 5 is 7. So that's not too bad, that's pretty straightforward. If I want to have a go at one of these slightly more awkward ones with negatives, let's just have a look at this last one here. Negative 3x subtract 5 equals x, add 15. Again, I want to get rid of the smaller amount of x. Now, you might initially think that the x on its own here is smaller, but actually if you think about it, -3 is smaller than 1. This is a 1x. So the easiest thing to do is actually to get rid of the -3. The reason we tend to do that is because to get rid of this I have to add 3x. And if I add 3x to both sides, I have a positive amount of x's, which is a lot easier to work with than ending up with some negative x's later on. So I add 3x to both sides, I'm going to get -5 equals 4x add 15. Then I need to subtract 15 from both sides to clear this away. -5 subtract 15, that's going to be -20 equals 4x, and I can finish there. And finally, let's divide it by 4. -20 divided by 4 is going to be -5 equals x. And for clarity, I might well write x equals -5 just at the end there. The final version we might come across is one like this, which is a bit more awkward because there's some brackets involved. I'm only going to do one of these, and I'm going to pick the last one with the negatives in there. The positives are a similar process. So I've got 3 brackets, 5x minus 1 equals 2 brackets, 7x plus 2. Job number 1, the easiest way to tackle this is just to expand all the brackets first. So 3 times 5 gives me 15x, and 3 times -1 gives me -3. 2 times 7 gives me 14x, and 2 times 2 gives me 4. Now you can see this looks exactly like the ones we just tackled in the previous video, in the previous example. So I want to get rid of the smaller amount, which is 14x, and that's going to give me x minus 3 equals 4. And then I can add 3 to both sides, and I have x equals 7. And actually that was quite quick and straightforward. Just expand the brackets first, and then you have an equation just like you had in the previous version. So that's a really quick recap of linear equations. And now we're on to solving inequalities. And I've got 3 examples to work through, getting kind of gradually harder. And what I want you to notice is that actually this looks incredibly similar to that first equation that we solved. It says 2x plus 1, and then really the only difference is I've got an inequality symbol here instead of the number, instead of just the equal sign. And actually that means I can tackle this in exactly the same way. I'd like to end up with just x on its own. So what I'm going to do is I'm going to clear out the 1, and I'm just going to subtract it from both sides of the equation. So that gives me 2x, 7 subtract 1 is 6, and I'm just going to hang on to the same inequality symbol. I haven't done anything weird, I can just keep the same inequality symbol. I've got 2 x's, so I want to divide by 2. So that gives me x, 6 divided by 2 is 3, and I can keep the same inequality symbol. What this is telling us is if I want 2x plus 1 to be greater than or equal to 7, then I need x to be greater than or equal to 3. We can test it. If x is 3, then this should all be equal and match up nicely. So 2 times 3 is 6, add 1 is 7, yeah. If x is anything bigger than 3, then the answer to this should be bigger than 7. And we can try it. Let's try 5, for example. So 2 times 5 is 10, add 1 is 11. Yes, that is bigger than 7. So as long as x is greater than or equal to 3, this first inequality will also be true. So you can see the process is exactly the same as solving linear equations. But now we can do one extra thing. We can now draw this on a number line. So if I put my 0 here, now x is greater than or equal to 3, so I draw my circle above the 3, x is greater, and because of the equals line, I need to fill it in, just like we talked about in the previous video. So we kind of have 2 ways of representing our answer, with this little algebraic statement, and also with this drawing on the number line. So let's have a look at another example. This time I've got some brackets involved. What did we do last time we had the brackets? Well, first we expanded them. So 3 times x is 3x, and 3 times negative 4 is negative 12. And I still need that to be less than 18. I want to get the x all on its own, so let's add 12 to both sides of the equation. And I end up with 3x, still less than, I'm not changing my symbol, and then 30. Final step is going to be to divide both sides by 3. So I have x, 30 divided by 3 is 10, and the symbol doesn't change. The equal symbol doesn't change as we work our way down, nor does the inequality symbol. It's not straight, it's not that difficult, it's not really different from solving linear equations. And then the final thing I can do is, if that's my 0 and that's my 10, I can draw my circle there above the 10, arrow going down, and because we don't have our equals line, we leave the circle empty. So I've got 2 ways of answering this question. Final example. This time I've got brackets and an x on both sides, but actually it's not super hard. Job number 1, expand the brackets. So 4 times x is 4x, and 4 times negative 4 is going to be negative 16. I'm going to keep my symbol there, and I'm going to keep the right hand side the same, no changes. The next thing I want to do, just like I did with those linear equations, is I want to get rid of the x on one of the sides, and I want to get rid of the smaller amount. So I'm just going to take away this smaller x, take away x. 4x take away x is 3x. Subtracting x isn't going to affect the number part. It's not going to change our symbol. The x has gone, so now we just have negative 1. And now it looks like the simpler version. So let's add 16 to both sides. So I've got 3x is less than or equal to negative 1 plus 16 is going to be 15. And then final step, let's divide both sides by 3, because then we get x all on its own. 15 divided by 3 is 5, and the symbol hasn't changed all the way down this process. No difference whatsoever. Okay, and that's it. 3 examples getting gradually harder, and really it's not very different from solving normal linear equations. You just have a different symbol down the end, and as an added bonus, we can now also draw this on a number line with a circle above the 5. We're less than, because of the equals line, we fill our circle in. Okay, so the task for this isn't a worksheet, but there's actually a task set on My Maths for you, and it's called Inequalities, and it just covers all of this content. You should be able to have a go at that now.